In previous videos, we have talked about using Kubernetes or KAS as a way of running Docker containers. We've also walked through how to set up an NFS server to do read, write, many shares in Kubernetes. Today we'll be taking that to deploy MediaCMS. MediaCMS is a CMS server that allows you to upload videos and then have that system retranscode them so that you can watch them on a mobile device or on a computer at varying resolutions. To do this, it has several parts. The first part is actually a web server. The web server is used so as we can upload videos and also watch videos. The web server stores these video files into the NFS server in a directory that we will set up for a PVC. It then uses Celery, and what Celery does is it allows a scheduled task or an ad hoc task to run, and these tasks can run on one of two different Celery nodes, one for long running and one for short running jobs. What we're interested in is the long running jobs. These long running jobs are transcode jobs, and what they will do is they will pick up the video from out of the NFS, transcode it through to a different format, and then push it back up into the NFS. That way we'll get our different resolutions. So let's get started. We will be basing our Kubernetes deployment on MediaCMS's Docker repository and on the MediaCMS image.
First, we start with the namespace that we can store all of this into. Next, we'll start with our web service. So this is the actual MediaCMS, calling it web. We're doing an init container. This init container will check to make sure that Postgres is up before we start. Once it detects that is up, we'll run our next init container, which will run through and do all of the Django database migrations. It will also set the user for admin in Django to what we pass in our secret, which we'll go through in a minute, what is in that secret. Lastly, we drop down and we actually start our MediaCMS. Because we have to actually make some changes for our local settings to override some stuff, we'll actually have our custom command. So this command actually overrides what the Docker container has internally for its startup command. We'll also set some resources to make sure that it doesn't consume everything within our cluster. Last thing we need to do is use this matrix of services to describe what it is that we're actually installing in this container, because everything uses the same container, and it uses these basically to switch personalities between what the container is actually doing due to the way that Django works. So we start up our Uwhisky server and Nginx, and we tell it that we're not running any of the Celery nor any of the migration. We let it know that we're serving out 2 ports, and we're lastly mounting in our volumes. The first one here is actually where our media is actually stored and is used as a NFS server using read, write, many, as our Celery workers need to access those media files in order to transcode. Next, we have a location to just store our logs so as we can persist those. And finally, our local settings override. And we pass through volume mounts, telling us our persistent volume claim and our secrets claim and our config map for our local settings. So continuing looking at our web server, we set up a cluster IP for our actual web service on port 80, which we will then use the ingress to consume and serve it out with this host. We must make sure that we pass in the annotation of proxy body size set to 0 so that There is no limitation to the size of the file we upload because some of our media files could be megabytes, even gigabytes in size. Next, we have our secrets. This secret is purely for the admin user in Django to consume. It is not the admin user in the web portal. Next, we'll set up a Redis server as it's using Redis to communicate between the web server and the Celery beat, which is controlling the Celery jobs. We also set up a service so as we can find it within the cluster. Being a Django, it needs Postgres. So we're setting up Postgres and we're just telling it to trust everything. We're not using tight security on this at all. We give it a location to mount our data in, and we limit how much memory and CPU the server can actually use. We once again create a PVC. This is just a read write once, and it's fairly small because this database will not be large. As normal, we create a cluster IP for our database so that our Celery workers and our web service can find it. We have our PVC, which is set to read write many for MediaCMS, and we've given it 1 terabyte of storage. Our local overrides. Now, the main thing in here is to make sure that we update our secret key, as that should be unique to your own installation for security reasons. We also should change our password that we're using for MediaCMS so that it's not just a simple password as is shown here. Next is our short worker. So the short worker is used to run jobs such as emailing a user that their transcode jobs are finished, and things like that. Things that take very little time to run. We are starting this up using a custom command because the scripts that are actually included in the image will start up a Celery worker with multiple workers. We don't want that. We want one worker per node. That way we can take care of our scaling using the horizontal pod autoscalers. As in the web service, we actually have to fill out the matrix here, and we're actually telling it that yes, this is the short worker. We mount in our media files and a log directory and our local settings, just like what we did back on the web server. The long is pretty much identical, except we're telling it that this is the queue for long tasks. So this is where our transcode jobs will run. And so every time we add a file to the MediaCMS server, it will go to start another long task to do transcoding. And we have our horizontal pod autoscaler that just goes and says, okay, we have a job, it's running, because our Celery worker has 1 task per server, it'll scale up and give us more service so as we can handle an influx of more workload. The last one is Celery beat, which is the controller for Celery. It will listen to our Redis queues, and when a new job is issued, it will then tell either the long or the short worker to perform that workload. And that's all there is in the configurations. Let's start deployment. In order to do that, we'll need to open up the command prompt in Visual Studio Code. To do that, it's Control-Shift-Tick, and then we're ready to deploy. So we're going to use the kubectl apply -f dot, which will deploy every YAML file in this directory. As it deploys them in an alphanumerical order, it will start with the 00 namespace, thus creating the namespace that everything will be deployed into. We can watch our deployments by using a watch command for kubectl, and we're going to watch for the get pods from the namespace of MediaCMS. As we can see, our web container is waiting on init due to the two init containers, the first one waiting for the Postgres starter to start up. The rest of them are currently pulling their containers. In a moment, they'll have their containers and they will start. There we go, the pod's initializing. And it's now running. So let's go and take a look at our website. So taking a look at the website, we can see that it's come up with an insecure certificate because our ingress controller is using internal certificates for signing for all HTTPS traffic. So we can just go advance and accept the risk because we know where it's coming from. And this is our MediaCMS site. At the moment, there's no videos in it. So what we will have to do is register, supply it with a email address, a username, give it a name, and give it a password. I've just used test, and as you can see it's too common and it doesn't like it. So now I will put in a tighter password that's got more characters and sign up. And we're now signed in, we're ready to upload media. So I will select to upload, I will browse for files. I am going to upload one of the videos that I've already uploaded to YouTube, and that will be our Pi-hole video. And as you can see, it's uploading. The next thing that it's going to be doing is actually doing a transcode on that video. And so at the moment there's nothing there. We can view it. It's telling us that we are pending an encoding, and we can now go back and we can browse and go to my media. And in fact, it's already done the thumbnail for it. This video, not being very large, should not take long to do. So now we'll take a look and we can see that our video is here. It's been transcoded and it has multiple quality settings. So that is how you can create your own YouTube at home. If you liked the video, please press the like button and subscribe. Thanks for watching.